Have you ever wondered what scientists meant by contaminated water? I'm Brianna Kurtz, and I'll be taking you through the process of finding out what's in the water. The purpose of this experiment was to identify unknown compounds found in different drinking water samples using infrared and nuclear magnetic resonance spectroscopy. Each of the water samples were contaminated with some kind of pollutant that is not safe for humans or the environment. How does IR spectroscopy work? It was done with a Nicolet IS5 FT IR spectrometer. IR spectrometry works by using infrared light passing through the sample to detect how much of it makes it through. Through this detection, the functional groups can be identified with the different photoabsorption rates. Different rates mean different functional groups. The spikes on an IR map show that a functional group is absorbing the infrared light and causing the percent transmitted to be lower. There's also a fingerprint region on the scan that causes indecisiveness on what is the exact functional group. What is NMR spectroscopy? NMR spectroscopy is collected at 60 MHz on an EFT60 spectrometer. It works by the sample is introduced to a magnetic field, and then the light is shown through the sample and detected on the other side. The number of peaks on the scan is the number of different environments the hydrogen atoms are in. Results section. Table 1 is a table of infrared spectroscopy with different molecules and their functional groups that were found. Table 2 is the NMR spectroscopy with the same molecules but in the number of peaks and the ratio of areas found. How the unknowns were found. They were found by, hold on one second, let me go back. Each unknown was found by taking the NMR and IR results for their sample and comparing it back with tables 1 and 2 and finding what they had in common. For instance, unknown 1, for the number of peaks and the ratio of areas, it yielded a methyl acetate or 1,4-dichlorobutane as the possibilities, and for the IR, it yielded the 1,2-dichloroethane or the 1,4-dichloroethane as well. This is Table 3, the IR spectra of unknown compounds with the functional groups found for each sample. This is Table 4, the NMR spectra of unknown compounds found for the number of peaks and ratio of areas for each sample. For unknown 31420, there is a CH group found in the IR and a CCl, but the CCl is in the fingerprint region, so it could be inconclusive. The CH is a singly bonded carbon. For the figure 2, there were 2 peaks with a ratio of areas of 1:1, and this yielded that there was a 1,4-dichlorobutane, and this is below the actual chemical structure of it. For unknown 60465, there was a CH benzene ring and a CH singly bonded carbon found in the IR, and there's 2 peaks in the NMR spectra with a ratio of areas of 3:2 with a paraxylene, and this is the chemical structure of it. For unknown 94086, there's a CH singly bonded carbon. There was also a CO. There were 2 peaks in the NMR and a ratio of areas of 3:2:1, and this yielded an ethyl formate, and that below is the chemical structure of it. What are some health risks involved with these different pollutants? 1,4-dichlorobutane could cause burning and irritation of the skin and eyes, irritation to the lungs when ingested, dry and cracked skin, redness, and water blisters. For ethyl formate, irritation of the nose and throat, coughing, shortness of breath, and a possible buildup of fluid in the lungs. It can also affect the nervous system. Paraxylene is a skin irritant. It can cause coughing, wheezing, headaches, nausea, vomiting, and dizziness. It is also a reproductive hazard, which makes it extremely dangerous to be taken in by humans. There's also effects on the environment by these. For dichlorobutane, it is harmful to aquatic organisms, so you don't want it in the water. For ethyl formate, it has low toxicity, so it's very low risk, and if it were to get in the water, it probably wouldn't cause a whole lot of damage. For paraxylene, it seeps into the soil, surface water, or groundwater. However, it eventually evaporates and then gets broken down by the sunlight within a few days, so there's really no effect on the environment. In conclusion, IR and NMR spectroscopy are valuable tools to use when identifying pollutants in contaminated water samples. They highlight the functional groups, number of peaks, and ratios of areas. This data led to being able to definitively tell which sample was and then what each sample was, and then research its health and environmental risks. I would say 1,4-diachlorobutane is the most overall risk because of its hazards. However, ethyl formate can cause worse health effects on 1,4-dichlorobutane and paraxylene. However, paraxylene does cause reproductive effects. And then these are the references.